V be a real polynomial, and then the transformation one is the T map P to XP. Second is derivative. I mean, if you know quantum mechanics, then you can solve this very quick. Okay, so what we need to show is the derivation for S and T, the algebra for S and T. So I claim ST minus TS is identity. If you know quantum mechanics, then you can know basically this is adopted from quantum mechanics result. But I can prove this very quickly. So ST of F is just S XF, and S is derivative, so X F prime times F, and the TS F basically is TF prime and XF prime. So ST minus TS, this term will cancel. The remaining term is F. So ST TS added acting on F will become F. So ST minus TS is identity. So the answer is D. The answer is D. 49. If a finite group G contains a subgroup of all the 7 but has no element, its no element is its own inverse, then the group order G. Two important theorems for the finite group. Actually, there are many important theorems, but we only need 2 of them. So the first one is the Lagrange theorem. If H is a subgroup of G, then the order of G is divisible by order of H. So that means from this statement we know that the group of G must divisible by 7. So we have, so A is not okay, B is okay, C is okay, D is not okay, E is okay. So we have BCD. And the second theorem is the Sylow theorem. The good thing is we don't need all the theorems, all the 3 Sylow theorems. We only need the first one. If G can be written as, so given prime, if G can be written as P to the R to the K, and the K is coprime to P, then G must contain subgroup of order P to R. Okay, so for the B, so if G is 28, then I can write down as 4 times 7. So that means G has an order 4 subgroup. But if G has an order 4 subgroup, this tells you that there are 2 order 4 subgroups. One is the Klein group, one is the Z4. So Klein group is Z2, direct sum Z2. But in Z2 direct sum Z2, 1 is its own inverse, right? Because if you add 1 twice, you get 0 in Z2. In Z2, and then in Z4 is also, because 2 is its own inverse, because 2 plus 2 is 4, which is 0 in Ma4. So G equal to 22 is not okay. Okay, so how about E? G is 42. This is equal to 2, 3, 7. This is the same, because G must contain subgroup of order 2. then the subgroup of order 2 must be Z2. So G must contain some element with its own inverse. So this is still not okay. So the only remaining choice is C, 35. We choose C.